How does geothermal heating work? Have you ever wondered how we can harness the heat from deep within the Earth? Geothermal heating is a fascinating process that taps into the natural warmth of our planet. In polar regions, this method becomes even more essential due to the extreme climates and the need for sustainable energy sources. Let's break down how this technology works, especially in places like Iceland, which is renowned for its geothermal energy. First, the Earth's core generates heat through natural processes. This heat comes from radioactive decay and the leftover energy from when our planet was formed. As this heat moves toward the surface, it warms up the rocks and water beneath the ground. In areas with high geothermal activity, such as volcanic regions, this heat is much easier to access. In Iceland, for example, wells are drilled into geothermal reservoirs. These reservoirs contain hot water or steam that can be brought to the surface. The hot fluid either rises naturally or is pumped up. Once it reaches the surface, heat exchangers come into play. These devices transfer the thermal energy from the hot fluid to water or air, which is then used to heat buildings, greenhouses, or even generate electricity through turbines. In the Arctic, geothermal energy plays a vital role in district heating systems. In fact, nearly 90% of homes in Iceland are heated using this sustainable energy source. Power plants, like those found in the Hengel volcanic zone, use steam to drive turbines and produce electricity, showcasing the versatility of geothermal energy. Geothermal heat also interacts with the environment in polar regions. For instance, in Antarctica, the heat from the Earth can warm the base of glaciers, affecting their movement. The Thwaites Glacier, located in West Antarctica, sits on an area with elevated geothermal heat, which contributes to its instability. When considering the practical aspects of geothermal systems in polar regions, it is important to note that they must endure freezing temperatures and permafrost. Insulated pipelines and heat storage solutions are necessary to maintain efficiency. In remote areas, smaller geothermal systems can provide reliable energy without relying on fossil fuels. Geothermal energy is a renewable source that is particularly suited for polar regions where sunlight and wind may not be consistent. It helps reduce dependence on imported fuels and supports sustainable development in these delicate ecosystems. While humans create geothermal plants for energy, natural geothermal heat also shapes the polar environment. In Antarctica, the heat beneath the ice influences ice dynamics, highlighting the dual role of geothermal energy as both a resource and a natural force. Looking ahead, expanding the use of geothermal energy in polar regions could help reduce carbon emissions and improve our understanding of ice sheet dynamics. Innovations in drilling and heat capture may allow us to tap into new resources in permafrost or beneath glaciers. In summary, geothermal heating is a remarkable technology that allows us to harness the Earth's natural heat. It is especially relevant in polar regions, where it provides sustainable energy solutions while also interacting with the environment in significant ways.